Welcome to video 4, converting rectangular to polar coordinates. In the previous video, video 3, we went the other way. We converted polar to rectangular. And the way we did that was we realized that if we had r and theta, we could get x and y by using the equations x equals r cos theta and y equals r sine theta. And so those are the two formulas we used to convert polar to rectangular. So now we're going the other way. So what happens if we have x and y, but we want it written in r and theta type of form? And so what can we do? Well, let's say we have x and y, and we'll see in our first example we have something like 3 rad 3 comma 3. That's going to be your x and y. So you have x and y. How could you get r? Well, pretty simply, we remember that this is a right triangle, and so you can get r by doing the Pythagorean theorem. And so if we write our Pythagorean theorem out, that would be x squared plus y squared, the square of the two legs added together, equals your hypotenuse, which we're saying is r squared. Well, we don't want r squared, we want r. So how can we get r? Well, we could take the square root of both sides. And so the formula for r is going to come from basically the Pythagorean theorem, the square root of x squared plus y squared. And notice that I just switched sides. If I had r on the right over here, now I moved it to the left, and that's fine because the left equals the right because it's an equal sign. So this is our equation that we're going to use to find r. If you have x and y, you're going to square them. And remember, squaring things, no matter whether x and y are positive or negative, when they square, they're going to go positive. Then we're going to add them together, and we take the square root of it, and that's going to give us r. How can we get angle theta? Well, how do we get angles from right triangles? Basic SOHCAHTOA. So again, we're saying we have x and y. Y is your opposite side, and x is your adjacent side. So how would you get angle theta? Well, we know that, let me just switch colors. We know that tangent theta uses those sides. Tangent theta equals, fix my theta symbol there. Tangent theta is opposite over adjacent, so tangent theta equals y over x. And so then you can use this to solve for an angle. And remember, the way we solve for angles is we do inverse functions. So we're going to change this to not just tangent, but inverse tangent y over x. So in our calculator, we get inverse functions by doing the second key in our calculator. So that's second tangent y over x, and that's how we're going to get theta. And so these are our two formulas we're going to use here. Radius from Pythagorean theorem, basically, and theta by doing inverse tangent. And so that's how we can find our polar coordinate from our rectangular coordinate. First example. So again, I want to go through the same process here as far as we want to state the quadrant, then we're going to convert, and then we're going to confirm the quadrant. And this last confirm the quadrant part, it becomes really, really important when we're going this way from rectangular to polar, because it's not always so obvious. So we'll see that in an example in a moment. All right, so this is our x and our y, and we want to convert it to rectangular. But first, what quadrant are we in? Well, if we remember just our simple concept that in quadrant 1, x, y is positive. In quadrant 2, x is negative, but y is positive. In quadrant 3, they are both negative. And in quadrant 4, x is positive, but y is negative. And this corresponds directly with ASTC. In fact, it's the reason for ASTC. But anyways, we see x and y are both positive here, so we know this is a quadrant 1 angle. And so our hope is the polar coordinate we get in the end is also a quadrant 1 angle. So we have two equations. We get r comes from the square root of x squared plus y squared. So let's start there. And so r equals the square root of, make sure you're using parentheses here, 3 rad 3 squared plus 3 squared. And then, so we need to do this algebra here. Now, 3 rad 3 squared, some of you may use your calculator for that. You can. You just have to be careful with parentheses. Like if we do parenthesis 3 and then do rad 3. Now, depending on your software, you may need to close parentheses. You may have to hit the right arrow to get out of the radical. Either way, square it, make sure the whole thing's in parentheses, and then square it, and that'll give you 27. So you can use your calculator to do that part for you if you'd like. And 3 squared, hopefully we all know, is 9. But 3 rad 3 squared, the reason why it is 27 is because the 3 squared in the front, that's 3 squared, that's 9. So 3 squared is 9. And radical 3 squared, well, radical squared, you get what's inside, so radical 3 squared is 3. So 3 squared is 9, rad 3 squared is 3. They are being multiplied, 9 times 3, and that's how you're getting 27. But you can use your calculator if you like. 27 plus 9 is 36, and so we get the square root of 36, leaves us with an r value of 6. Next, we get theta by using the formula of inverse tangent. So inverse tangent y over x. Inverse tangent y over x is how we're going to get our angle thetas. And this is done completely in the calculator. And so let's look at that. This would look like inverse tangent y divided by x. The y value is 3 divided by the x value of 3 rad 3. And you can type that in as is, just make sure the whole bottom's in parentheses, but if we want to simplify it, we can. Let's simplify it just so it's a little bit easier. You can simplify those 3, so that'd be 1 over rad 3. Again, you don't have to simplify it. The calculator can go as this, but be careful with parentheses. And so we're going to type this in. And now you may be thinking, well, shouldn't we rationalize the denominator? But the calculator doesn't really care about that, so we don't need to. So second tangent is how we get inverse tangent, not regular tangent. Second tangent, 1 divided by radical 3. Get out of my radical, close parentheses, hit enter, and we get 30 degrees. Now make sure your mode is on degrees, otherwise that's not going, it's going to give you something else. But the answer is 30 degrees. And so we have theta equals 30 degrees. Put it together, 6 comma 30 degrees. Is this also a quadrant 1 angle? Yes, it is, and so we confirm we're in the proper quadrant, and so that's it. Let's look at another example. -1 rad 3. This is a quadrant 2 angle because we have a negative x and a positive y. You refer back to this diagram, negative x, positive y, that's quadrant 2. So let's start with r. The square root of -1 squared plus radical 3 squared. -1 squared is 1. Remember, negative square positive. Radical 3 squared is 3. 1 plus 3 is 4. Square root of 4 gives us r equals 2. For theta, we do inverse tangent y over x. That's radical 3 over -1. And we type this into our calculator. So we'll do second tangent. I could just do negative radical 3 instead of rad 3 divided by -1. I mean, it's the same thing. Just a couple less buttons. And that gives us -60 degrees. Now, we know now we could just add 360 anytime we have a negative angle to convert it positive, because we tend to prefer positive angles. And so that would mean that angle theta equals 300 degrees. And that gave us -60, but we added 360 to it, and that's how we're going to get a positive 300 degrees. And so our coordinate would be 2 comma 300 degrees. But maybe you notice a problem. Is that quadrant 2? No, it is not. 300 degrees, well, 300 degrees, that is in quadrant 4, not quadrant 2. And so this is where you have to be careful, and you have to make sure to confirm your quadrant, because the calculator doesn't really know what quadrant you're in. When you do inverse functions, and maybe you remember this from Algebra 2, the ambiguous case and stuff like that, you know, for a simple example, like sine 30 is 1/2. So is sine 150. Sine 150 is also a positive 1/2. So when you do inverse sine 1/2, the calculator doesn't know if you're talking about quadrant 1 or quadrant 2. So it gives its best guess. When you do inverse functions, there's almost always 2 angles, but your calculator is only going to give you one of them. And so you have to make sure that it is the right one. In the previous example, the calculator gave us 30 degrees. That was in quadrant 1, so we were good to go. But in this example, it's giving us 300 degrees. That's in quadrant 4, not in quadrant 2. So, is it completely useless? No, it is not, because it gives you an angle that's not in the right quadrant, but it gives you an angle that is a reference of what you need. So we know we need an angle in quadrant 2, and they're related to each other. 300 is a reference of 60 because it's 60 away from 360. And so we want a reference of 60 in quadrant 2. And in quadrant 2, the reference of 60 means 60 short of 180. That would be 120. And so that is really the angle we need. So 2 comma 120 degrees. And that is a quadrant 2 angle. That's our correct answer. So you do need to be careful with these when you're doing inverse tangent. Make sure the angle the calculator gives you is the right quadrant. And if it doesn't, it's giving you a reference of your angle in the right quadrant, or a reference angle for it, and you can kind of figure it out from there. One last quick example. What happens if we're given an angle like 0, -4? What quadrant's that on? It's not. That's between quadrants 2 and 3. That's on the axis itself. This is a quadrantal. And so that would be between quadrants 2 and quadrants 3. It's on the axis. And so we can still do r the same. When one of our values is 0, it's pretty simple though. 0 squared plus -4 squared. And 0 squared is 0, -4 squared is 16, and so we end up with 4. So r equals 4. If you do inverse tangent here, whoops, let me go back to the thin marker. If we do inverse tangent, we end up with -4 over 0, but the problem is that is undefined, and your calculator is not going to be able to work with that. I think when you know your angle is quadrantal, when you know it's on the axes, you're better off just doing the angle by sight. Depending where I am, I know these angles are 90, 180, 270, and 360. And so where is 0, -4? It's at the 270 line, so my angle theta is 270. And tangent 270 is undefined, so I could confirm that if I needed to. And so my answer is going to be 4, 270. Is that between quadrants 2 and 3? Yeah, it's exactly where it is, and so that's I think actually a little bit easier when it's quadrantal. You don't need to worry about doing inverse functions. You could just kind of draw this basic little picture over here. All right, that's it. See ya.